Hello everyone, hope everyone is doing well. Today we are going to see how to test if the variances of two different samples are equal or not. So in our case, let's say we have collected two samples, N1 is 55 and N2 is 40. And we found these two standard deviations, where standard deviation of the first sample is 15 and the second sample is 19. So what we are going to do is test, basically, in our case, H naught is that sigma 1 squared equals sigma 2 squared. So basically the variances of these two populations are equal. Note we are not using S1 and S2 here because, as we are testing, in hypothesis testing, we always test for the population. And the alternate is that sigma 1 squared is not equal to sigma 2 squared. So as we can see, this is then going to be, since it has a not equal to, this is going to be a two-tailed test. And another thing to note is that we have here our standard deviation. So we have S1 bar and S2 bar. But we are testing for variances. So we need to convert the standard deviations to variances. So let's do that. Let's say variance 1. And we have variance 2. So variance 1 would be the 15 I have squared, and variance 2 would be 19 squared. And we have our N1 and N2. Now, to do this test, we are going to use something called an F distribution. So we are not going to use the normal distribution or T distribution. We will use something called the F distribution. It is a different kind of distribution, and it takes in basically the F value, which we will find, or the F stat, and then we are going to compare it with the critical value of F and then do our analysis. So in our case, how do we find the F distribution from here? We have our variances. What we will do is we will find the F stat. Now, in my case, what I will do is I will make sure that which number or which variance is the larger one. So I find that this one is the larger one, so that will be in the numerator. So 361 divided by 225, this will be my F stat. Now if you notice that F stat, at least a couple of things to notice. In this example, F stat will be greater than 1, and F stat is going to be, and that is mainly because the larger variance is going to be in the numerator and the smaller variance is going to be in the denominator. So this is my F stat, and we also have 2 degrees of freedom. In my case, so we will have degrees of freedom 1. Now it's going to be the numerator's value, sample size, minus 1. So the numerator was sample 2, so it will be 40 minus 1. So my first one is 40 minus 1, and my second degrees of freedom is going to be, which is the second one, is 55 minus 1. So it's 54. Now, we are going to compare this F stat with the critical value of F, and that's why we need the degrees of freedom. So I will write the critical value of F here. And the formula will be F dot INV dot. We are going to do RT, right tail. Now, if you remember the probability, let's say we are testing alpha at 0.05. So let me write it here. Let's say my alpha that I'm testing is 0.05. So when I'm writing f dot INV, I'm doing the right tail test. And the probability, since I said it's going to be a two-tail test because we're testing whether the variances are equal or not equal. So the probability will be, again, what we have been doing with our normal distribution and T distribution whenever we have a two-tailed test is divided by 2. Degrees of freedom, the first degrees of freedom would be the one for the numerator. So numerator, and the second one is for the denominator. And I close the bracket, and my critical value of F is 1.778. So I can see the F distribution here kind of looks like it is like this, and we are doing a right tail test. That should not go up, kind of like that. Now this is going to be my critical value of F, which is 1.77. And this is anything greater than that is the rejection region. And since we have a two-tailed test, so there's going to be another rejection region here, but since we did a right-tailed test, we don't need to find it. We could find it if we did f dot dist and then found it, but for us, since the numbers are always going to be positive, and we are always looking at the right-hand tail, so we don't really need to find this value. So after we find that, now we can do our test, which is the f-stat is 1.60, which is going to be somewhere here. So then we can say that the f-stat is less than the critical value, so we do not reject the null. Now, instead of finding the t or f critical value of f and then comparing it with this graph like this, I can also find the p-value of this f-stat. So what I would do is basically convert this f-stat into a p-value and then compare it with the alpha, which I have right here. So the formula would be f dot dist dot rt x, which is the f-stat, which is this one, comma. Degrees of freedom is the degrees are the number of observation minus 1 of the bigger value, so which was the standard deviation. The larger one was 19, and so it is 40, so which would be this one. And degrees of freedom of the second one would be that. Now, since we were doing a two-tailed test, we have to multiply this number by 2, and we get a p-value of 0.1071. So I can see that the p-value is greater than alpha. So we can say that we did not reject the null. So therefore the null cannot be rejected, and so the standard deviation of these two numbers are pretty equal, or the variances of these two numbers are probably equal. Now, there is also a pre-canned program in Excel that does this analysis for you. But since it's a very simple analysis, I'd rather do it by hand, and you can get it and the results pretty easily. But basically, if you wanted to do it, you would have to go to Data and Data Analysis, and then you would go to F-test 2 samples for variances. Click on that, and then you would add the data ranges for x1 and x2. So your 2 samples, you have to have the raw values for that. Select if you have labels in it, alpha, and then click OK, and it would give you the result. But since we don't have the raw values, we just have the regular numbers, so we are going to use just our simple a division and some looking at the F tables to find out our results. Hopefully this was beneficial, and I will see you at a later video. Have a good day.